Have you ever wondered what the CPU in your computer does? Well, if you have, you're in the right place. The CPU, or Central Processing Unit, is the core component of a computer and plays a pivotal role in practically every action your computer performs. Think of the CPU as the brain of your computer. Just as our brain controls our body, the CPU controls the computer. It's responsible for executing every instruction, from the simplest to the most complex, that your computer needs to perform. Whether it's opening a document, playing a game, or browsing the internet, none of it would be possible without the CPU. Now, let's focus a bit on what makes up a CPU. At a high level, a CPU is composed of several key parts that work together in harmony. First, there are cores. These are the workhorses of the CPU, carrying out the instructions the computer needs to function. Modern CPUs often have multiple cores, allowing them to perform several tasks simultaneously, which we refer to as multitasking. Next up are the cache and the registers. The cache is a small amount of high-speed memory that stores frequently used data, while the registers hold data that the CPU is currently processing. Both these elements contribute to the speed and efficiency of the CPU. Then we have the arithmetic logic unit, or ALU, and the control unit. The ALU performs all the mathematical and logical operations, while the control unit directs all the operations within the CPU. Finally, we have the bus interface, which connects the CPU to other components of the computer, allowing it to communicate and coordinate with them. In a nutshell, the CPU is a complex piece of machinery, intricately designed and composed of several parts, each playing a vital role in making your computer function as it should. Now you know that the CPU is the computer's brain. But what does it really do? Let's dive in. So, what's the job of this brain, the CPU? Well, the Central Processing Unit, or CPU, is a multitasking whiz. It's the primary component of a computer that performs most of the processing inside the computer. Its primary functions can be broken down into 4 stages: fetching, decoding, executing, and storing. Imagine the CPU as a busy office worker, always buzzing with activity. The first stage, fetching, is akin to our worker collecting a pile of paperwork from the inbox. This is when the CPU retrieves an instruction from the computer's RAM, or random access memory. Next, our office worker must understand what the paperwork says. This is the decoding stage. The CPU deciphers the instruction it is fetched. It determines what operation it needs to perform, be it addition, subtraction, comparison, or something else entirely. Once the instruction has been decoded, it's time to get to work. In the execution stage, the CPU performs the operation. It might be crunching numbers, moving data, or making decisions based on the information it has. Finally, after all the hard work, the results need to be stored safely. In the storing or writing stage, the CPU sends the results of the executed instruction back to the RAM. It's as if our office worker has finished processing the paperwork and files it away neatly in the outbox. Each of these stages is crucial for the computer's performance. Fetching ensures the CPU always has instructions to work on. Decoding allows the CPU to understand what it needs to do. Execution is where the real work happens, and storing ensures that nothing is lost. Without these 4 stages, the CPU wouldn't be able to process information or carry out tasks, making it a vital part of any computer system. It's like a tireless office worker, always fetching, decoding, executing, and storing, ensuring that the computer runs smoothly and efficiently. As you can see, without the CPU, your computer wouldn't be able to perform any tasks. But how does it accomplish all this? Well, let's delve deeper into the parts that make up a CPU in our next scene. To understand how the CPU performs its tasks, we need to know its components. Picture a bustling city with various departments working in harmony to keep everything running smoothly. That's essentially what's happening inside a Central Processing Unit, or CPU. There are 3 main components that make up a CPU: the arithmetic logic unit, the control unit, and registers. Let's delve into what each of these components does. The arithmetic logic unit, or ALU, is like the city's workforce. It's where all the mathematical operations like addition, subtraction, multiplication, and division take place. But it's not just about numbers. The ALU also performs logical operations, such as comparing 2 numbers to see which one is larger. It's a hive of activity, crunching numbers and making logical decisions, all to ensure the system works as it should. Next up, we have the control unit, or CU. Think of it as the city's administration. It directs all the operations of the CPU, coordinating and controlling the activities of the other hardware components in the system. It interprets instructions from the memory, transforms them into signals, and sends them to the ALU, memory, or other parts of the computer. The CU is the maestro, conducting the orchestra of hardware components to create the symphony that is your computing experience. Finally, we have the registers. These are the city's storage facilities. They're small storage areas within the CPU, holding data that's currently being used or processed. There are different types of registers, each with its own specific role. For instance, the accumulator register collects the results from the ALU, while the instruction register holds the instructions currently being executed. These components work together to ensure that the CPU performs its tasks efficiently. But how does the CPU communicate with other parts of the computer? The CPU doesn't work in isolation. It communicates with other parts of the computer. Imagine the CPU as the brain of the computer. And just like our brain, it needs to communicate with other parts of the body, or in this case, other components of the computer. But how does it achieve this? Well, it employs something called the system bus. Now, the system bus is kind of like a highway that connects the CPU to the rest of the computer. It's a set of physical connections, wires if you will, that carry data back and forth. The system bus has three main parts: the data bus, the address bus, and the control bus. The data bus is like a multi-lane freeway, carrying data to and from the CPU. The address bus, on the other hand, is like the GPS. It tells data where to go. The control bus, meanwhile, carries signals that oversee and direct all this movement. Now, here's where things get interesting. The speed of this communication, the rate at which data travels along the system bus, greatly affects the computer's overall performance. This speed is referred to as the bus speed. A higher bus speed means data travels faster, which in turn means faster execution of instructions by the CPU. But it's not just about speed. The width of the bus also matters. Think of it this way. A wider data bus can carry more bits of data at once, just like how a multi-lane freeway can accommodate more cars. So a wider bus can lead to better system performance. However, keep in mind that increasing the bus speed or width is not a magic solution for a super-fast computer. These elements need to be balanced with other system components for optimal performance. Now we know how the CPU communicates with other parts of the computer. But how does all this translate into the tasks we perform on the computer? So, how does the CPU affect your everyday computer use? Well, let's think about this. When you're browsing the internet, your CPU is working hard to render all the data into a visual format that you can understand. Each click, every video stream, all those cat GIFs, they all require processing power. Likewise, when you're playing your favorite video game, the CPU is there, handling complex calculations to bring your virtual world to life. It's your CPU that enables those smooth graphics, quick load times, and responsive controls. And then there's software use. Whether you're editing a photo, designing a 3D model, or crunching numbers in a spreadsheet, the CPU is the one doing the heavy lifting. A more powerful CPU can handle these tasks more efficiently, resulting in a smoother, faster experience. So, the next time you use your computer, remember the vital role the CPU plays. It's the brain that makes it all possible.